And so for homework, I asked you to add a couple of new behaviors. One, that if you leave the edge of the screen on one side, you'll show up on the other. That's a very standard asteroids behavior. It should also work for the left and right and top and bottom. So you basically go off one edge and you appear on the other side. In addition, I asked you to implement the behavior so that if I stopped pressing the keys, that I gradually came to a stop. This is, I wanted you to not just instantly come to a stop, but actually have you apply a concept of drag so that you'll gradually come to a stop. It doesn't, real space doesn't work like this, obviously. So this required a little bit of thought into how you can make something come to a halt smoothly, right? Was anyone actually able to get the drag portion of the asteroids working?
Mine slows down.
Anyone actually did it?
Like drifts.
It drifts? It continues to move?
Completely stops.
Almost completely stop, but it continues to move a little bit?
It does like very, very like by minuscule, like almost like
0.0001 movement.
Yeah.
Okay.
But, like I can see the number change. Like on the position it triggers me. So.
Okay. It's for all practical purposes, as long as it appears to come to a stop, that's the important thing. So I want to spend some time going over how I would implement this. It's not obviously the only way you could implement it, but this will hopefully help us get to the place where we can fly around the space field with our ship and not have to worry about losing it or flying too fast. There's one other thing I want to go over, which we didn't get a chance to talk about in lab. It wasn't for homework. This will become more important. Once I implement the teleporting so that the ship goes off one side and appears on the other, we have to implement the concept of a maximum velocity for our ship. If you don't do this, your ship will go too fast and will not be able to stop. And this is something that I want us to do together as a group. Okay, so I have this code that is responsible for moving the player. This code is in the player update function, and this code basically just adds the velocity to the position every frame, and then updates the sprite to be based on that position. So right in between these two, I'd like to put some behavior to detect if the ship is off one edge of the screen or the other, and then correct the position if it is so. And I'm going to do one piece at a time. I just want to test so that if I end up on the left side of the screen, I'll appear on the right side instead. And if I just look at the X position and it's less than 0, I know that the ship's off the left. This is a lot like how we did our Pong, the ball scoring, right? If the ball went off the left edge of the screen, before you would either give a point or initially you would also have it bounce off the walls if it was the top and bottom. So instead of bouncing or giving score, we're going to just move the position to the other side. Oh, thank you. So here I'm just setting up one if statement that says if the position of X is less than 0, which means it's off the left side of the screen, make it equal to the right edge of the screen. Now everything else remains constant. Like my velocity and my acceleration remain unchanged. I'm just fixing up the position of where the ship is, right? You guys can see what I'm talking about with the acceleration. There is no maximum speed for the ship, so it just kind of goes forever, and it will forever accelerate as long as I'm holding down the up key, and it'll accelerate 100 pixels per second. And there's no way to actually stop it. And actually, it's kind of interesting because if I go off the bottom edge of the screen, I'm just gone. Like it's hard to come back. So we know that this behavior works. So we can do the same behavior for the right side. We'll just reverse it. And we can test it. And I highly recommend you guys test as you make these changes. So I go off the left and the right. I appear on the left. And then if I change up my acceleration here, I can go on the other side too. Cool. I'm going to increase my acceleration slightly. And I'm going to take all this logic, I'm going to duplicate it, and change it for Y. Pretty straightforward stuff. Any questions on this? So now I am forever constrained to the screen, which is nice, so I'll never end up outside the bounds of it. Unfortunately, if I let go, the ship also just doesn't stop. It doesn't come to a stop at all. Okay. So the way that I want to implement this this deceleration, I want to have something set up so that if my curve, if my speed is represented on this line here, I want my deceleration to go like this, right? I want to slow down quickly at first, and I can exaggerate this more, right? I want to have a curve like that where it slows down pretty quickly and then comes to a halt near the end, which means I have to take my velocity and use my velocity to determine how much slower I want to go. So what I can do here is I can detect if I'm not currently pressing the up key, which means that I'm currently not accelerating in a direction, what I want to do is I already set my acceleration to 0. I also would like to slow down the velocity. So what's one way I could slow down the velocity? Well, I could take my velocity, I could subtract 10 from it, right? But what will this do if I slow down my velocity?
Oh yeah, because you go in X and Y.
It's increasing my velocity in negative by minus 10 every frame. If I multiply this by dt, I'm moving my ship actually. What am I? I'm actually trying to move this way, and my ship is actually going to be decelerated. Let me crank this up here. What if I took this velocity and just subtracted 300 from it? Watch, I'm getting pulled to the left here. See how my ship is actually like going backwards here?
Gravity.
But you can see the movement here, right? Like right before it starts going the wrong direction, it actually kind of does look like it's slowing down. Like if I'm going this way here, right? The problem is it's moving even though I am not, even though I'm not pressing the key. So I'm not pressing the key. How do I make this so that it actually only subtracts if I'm actually moving in a velocity? Well, why don't I use the velocity itself to determine how much I should decelerate? So if I set this up so that I'm subtracting the x velocity and I'm multiplying it by dt, you guys can see what's actually happening here when I take the velocity. What happens when this is 0? Nothing happens, right? What happens when this is 100? Well, I'm subtracting a portion of the velocity away from the existing one. I'm taking 100 and I'm multiplying it by delta time. This becomes a pretty small number. However, this number is proportionately large compared to how fast I'm going. So the faster I'm going, the faster this factor is in this expression. So by taking this value, the velocity, and including it in the equation, I am subtracting the velocity from itself. I am now slowing myself down based on how fast I'm going. And I can do this for x and y. That's all you need to have it apply drag. So I'm not moving, so I'm going to let go. You can see, watch as I move fast here. I'm going to let go. See how proportionately it came to a halt pretty quickly? Even though I am moving pretty fast. Right? And you can increase or decrease the rate at which you decelerate by multiplying this by some value. If I multiply that by 5, for instance, I come to a halt much, much faster, 5 times faster. See how my ship basically almost like puts on the brakes immediately, comes to a halt. So you can use this, and you can also decrease the amount that you decelerate. If I multiply this by 0.2, for instance, now it's going to take 5 times longer for me to slow down. But the rate at which I slow down is still based on my speed. So you can see it takes like about 10 times longer to slow down compared to the other method. So that's how we apply drag. We can take this value here. We can create a variable if we want to. Call it the drag factor. I'm going to set it to 2. And I can just multiply it here by 2. Just because if I want to tune the velocity deceleration, I can do that here. And I can do the same thing for acceleration rate. And I could create a variable for that and replace this here. Okay? All right. So now we have our ship and it's slowing down like I want it to. Okay. Okay. Questions on that? It's a surprisingly simple equation, but the key is that you want to take your velocity and make that the determining factor for how much you slow the ship down by. Okay, any questions?
You are a genius.
No, this is physics. So what I'll do is I'll put this engine folder into Zool because I want you guys to do a lab with me to start, and then we'll move on to today's lecture. If you didn't get this homework done, then this is actually the solution. You can take this whole thing, and looks like I have some more homework. Okay, so in Zool there's an asteroids folder, and let's go over the what I want you guys to do for lab.
Is the asteroids folder what we just did?
Yeah, this is what I just did up in front. Okay. So our game has a problem, and I'd like for all of you guys to help me fix it. And the problem is, as I mentioned, if I have a really high acceleration, like let's say I accelerate at 1,000, go. So I'm holding down. My ship is accelerating at 1,000 pixels per second, and as long as I'm holding down the arrow keys, it's going so fast that, or it's barely showing up on screen for a frame. I want to not have that because that's not what asteroids is about. Like positioning your ship in a way to blow up the asteroids correctly. It's not about flying as fast as you can. In fact, quite the opposite. So how do we solve this problem? What do we have? I want you to limit the velocity so that he can't move more than 500 pixels per second. Anyone have any ideas on where we could start to do that? Anyone have?
Get his x and y velocity, and if they're greater than our max velocity, set it to max velocity.
Okay. So if I am moving this way at 1,000 per second, I will limit it to 500. What about this way?
Negative 500.
Negative 500? What about this way? What is the x component of this? And the y component of this?
The x and y velocity values.
Yeah, what is x and y? If I'm moving diagonally up and left, what is the max speed for diagonally up and left?
Negative something.
It's negative some value, right? Well, what if I know that I'm moving to the up and left at 1,000? What are x and y here?
You do the math.
750 as well.
750? Let me check your work here. Nope, that's 1060. 750 is not the correct result. So what I want to do, you guys have kind of the right idea at first, but what I want to talk about is there is another way to solve this without having to create a condition based on the x and y components. So let me talk a little bit about a couple new linear algebra. These are pretty common concepts, but I want to talk about them here. I want to talk about calculating the size, which is calculating the speed, which we've done before actually, and then talking about normalizing vectors and how we're going to use that to limit our speed. Okay, so I'm going to draw a little arrow here. I don't know if I can draw that arrow any better. It's fine. What's up, Cody? Good. So what we're going to do to limit the velocity of our ship is we are going to find out first the direction that you want to go. And then using the direction that you want to go, we're going to apply your velocity to that direction. Okay? And this is going to be a little bit different than what we've been doing, which is we're basically calculating the x and y component of where you want to go, and then using that to control your speed. But to do that, we're going to first have to go through a couple of equations to figure out how we get to limiting your speed. So going back to when I first talked about this, I don't know how many of you guys remember about how do I find the value for h here. What is h equal to in this case? If I have
plus b squared.
a squared plus b squared? So square root of a squared. What is a and b in this case? X and y. So how do I calculate what h is here? Right? So 700 squared, right? Plus 300 squared. 300 squared plus 700 squared. What's that? And then square root of this? Bless you. Where is the square root? 761. Yeah, the hypotenuse will always be greater than one of its sides, so you'll know that that answer is correct if that number looks bigger than one of its sides. So first of all, why do we need this? Well, we need this because I want to do what's called a normalization of the components. So the reason why I want to do this is oftentimes when you're dealing with vector math in games, when you're dealing with directions in games, you don't want to have a number like 700 and 300. You want everything to be on what's called a unit vector. Let me see if I can find a good explanation for this. Okay. So in a lot of cases, when I look at something like a vector here, this vector here is 761 units long. I don't really care about how long it is. What I really care about is the direction that that vector is facing. Okay? I don't really care about the fact that it could be 700 units long. It could be 7,000 units long. It could be 7 million units long. Does this vector change direction if I add a 0 to the end of these numbers here?
No.
No? What if I add another 0, right?
No.
Let's say I'm moving on a ship that has light speed capabilities and strictly moving that fast. I don't really care about the speed in what I'm about to do. What I care about is the direction that the vector is going. So because I care about the direction, what I actually want is I want to deal with numbers that are between 0 and 1, no matter what the size of those units are. I want to take this vector and I want to put it between, give me a number between 0 and 1, because no matter what the magnitude of that vector is, I want the direction to always be the same. So I want to deal in a space that means that this hypotenuse value will always be the same no matter how long the vector is. And the way that you do that is actually rather simple. You just take each of these x and y components and you divide it by the length of the vector. So you divide it by the hypotenuse here. So if I were to take x and y and I were to divide it by h, I would get the same number no matter how big or how many zeros I add onto each side. X and y would turn into numbers that go between 0 and 1, guaranteed, always. There's no chance that I will get an x and y. If I divide x and y by the hypotenuse, I will always get a value between 0 and 1. And I will get the same value that's between 0 and 1, no matter how long my vector is, as long as my vector is facing the same way. What that means is I can get a direction that I'd like to travel, not caring about how fast you want to go. Then what I can do is I can take this direction here. Let's just get rid of all this. And I know that this direction here that's facing the up and right is where you actually want to go. Get rid of all this. So that black vector here is the direction I'd like to travel. The reason why this is important is because that's what we want to deal with in asteroids. When the player says he wants to move, I really just want to give a direction, and then I will control the fastest he can go in that direction. Whereas right now, he's specifying how fast he wants to go, and there's no real good way for me to control that. But if I knew the direction he wanted to go, I can just say, hey, take this speed that I want you to travel at, and make sure this speed that you travel at in that direction is not faster than this number. Okay. Let me show you what this means in practice. So what I want to do is first, let's calculate a few of the interesting pieces of information that I have here. So first of all, right in between the velocity and the position calculation, I'm going to print out what the velocity is. And I'm printing this out so that you guys can see what the velocity actually turns into as I'm holding the key down. You guys can clearly see I'm going really fast in that direction. And if I go at an angle, the x and y components tend to kind of go or grow at similar rates. Okay. So what I want to do is I want to print out how fast I'm going. As opposed to printing out the x and y, I want to print out effectively the hypotenuse. In this case, hypotenuse represents our speed, right? And remember, that speed is the square root of a squared plus b squared. So you can see our speed on the left now represents, no matter what direction I'm going, my speed is always going to be positive, right?
Yeah.
Because it represents basically, think of like speedometer, right? When you're driving a car, you're not going like negative 70 miles an hour just because you're heading south or whatever. That speed is basically the magnitude of our hypotenuse here. We did that formula. So now we know how fast we're going. what we can do now is we can take that information and we can control how fast we want to go. What if we were able to limit that number to be 500 instead of whatever max it's going at right now? So this speed variable now represents a single value we can compare against. Now remember I said that you're going to need to figure out the direction that you're traveling as opposed to how fast you're, like what direction and magnitude you're going. So how can I use this number to my advantage? How do I take this number, which I can see now? I can put an if statement here, right? And I could say like, I can print out something when I'm going over 500, so I know that. You can see here, I know that I'm going too fast, but how do I take that information and change how fast I'm actually going? Well, how do I change mVelocity.x to clamp it? We're back to our same problem, right, of before, of how do I take this? This might be negative, this might be positive, this might be a really, really small number, but I need this number to be controlled by the max speed that we specified. So what we're going to do here is we're going to take this velocity and we're going to do what's called normalizing it. So I'm going to divide it by the speed, and I'm going to take the x and y and both divide it by speed. This right here is now what's called our normalized vector, and this represents our direction. And I'm going to show you what this looks like now. What this will represent now is this will represent a number between 0 and 1. Oops. I'm going to make a new vector to copy this. I make a vector called direction. I just equal to mVelocity. So if you guys can see here, when I'm going to the left here, my direction is mostly negative, but it's never greater than 1, right? So there my direction is negative, almost close to 1. If I'm going up, my direction is mostly 0 in x. It's like 0.33 and almost to negative 1 in y because I'm going up. If I go down, that number turns into 1. This represents a value that exists on what's called a unit circle. So if you ever look up a unit vector, there's this concept of a line that points and goes right to the edge of this circle that has a radius of equal to 1. This vector here, which represents our direction, this little arrow will never go past the edge of this circle. This circle has a radius of 1, which means that this vector, because it lies on the edge of the circle, it's never shorter than the circle either. This vector is considered a unit vector, which because it lives on the unit circle. Unit circle just means it's literally a radius of 1. So that's really what it means. And the vector lies on the perimeter of this circle. So that's why when you're looking at the values for this, when you see the values for the direction, it always is less than 1. Because if I'm going to the top left, it's like I have a vector that's over here on the unit circle. So what is the x and y part of this? If you were to draw this on a chart, like so, this being 1, this being 1 up here, all these edges of the circle coincide with the values of 1 on x, negative 1 on the x on the left side, and 1 and negative 1 here. So the way we can use this information is that we have this value here, which represents our direction. What we can do is we can take this now and we can multiply it by the speed that we'd like to travel. If we take this, let's say I'm moving to the right, okay? If I take this number, 0.997800, and I multiply it by 500, I get 498, which means that I can take this x component, multiply it by 500, and I'll get a vector component that is less than 500, but moving in the right direction still. So I'm going to basically take this unit vector that I drew here, and I'm going to extend it out by multiplying it by some number to get me how fast I want to go. So in this case here, what I can do, watch what happens when I If I take this direction, which I'm currently printing out, and I just take this direction, I replace the velocity with the direction here, which means that I'm just going to take the direction, I'm going to add it into position instead of taking the velocity and adding it into position. Oops. Let me make sure I'm actually allowing me to do this. I didn't initialize my velocity correctly. So I'm actually pressing up right now. Can you guys see my ship barely moving? Because look at my speed is -1 in y. It's super tiny because it's a really, really small vector. It's only 1 pixel high. But what if I took that number and I multiplied it by something, right? What if I took direction here, right before I added it, and I took x and I multiplied it by, I don't know, 500, and I took y and I multiplied it by 500 as well? What if I took that really, really small number for the direction and I just multiplied it by a really big number? Oops. Make sure here I got everything that I need to initialized. Velocity is good. Speed. I'm dividing by 0 here too. What I got to do so I'm tapping up and it's moving me 500 pixels per second every time I tap up because I'm taking that tiny little vector and I'm increasing the speed by 500. So what I can do is instead of doing that, I have a speed already. I can take this speed that I calculated from earlier, how fast I was going, and I can just apply it to the direction. This right here is going to give me the same exact result as what I had originally when I started the asteroids program. So I have the same behavior where I accelerate over time. I'm still going over the speed limit. But all the changes that I made now let me change the speed. So if my speed is greater than 500, I can just make it equal to 500 here. This right here is the key to limiting your max speed. Now that we have a single number, this is not a vector, this is a single float that represents how fast I'm going. And I can tell when it's over 500, I can just set it equal to 500. Then I can take this number and I can multiply it by my tiny unit vector to get me my real direction of where I want to go. This number might be 500, but it might be really small too. It might be less than 500, it might be like 10. What this means now though is that when I'm moving my ship, my speed will never be allowed to be over 500 because I'm always moving in the direction that I like to go and then multiplying it by the speed. So if I print out my speed now, you can see my speed on the left here. It goes up to 500 and then stops, right? Okay, you guys all understand how to do that? Hopefully. All right, I'd like you guys to try to do that, implement that on your labs, the ones that you got from Zool, and then see if you can get your speed to be limited to 500 as well. If you understood how I did it here, you should be able to reproduce it on your own too. Try to do it without having to look up here. I'll keep the the code up here, but see if you can remember how to actually calculate the speed yourself.